let me start with the project background. First and foremost, Aquaponic planting system with STM32 nuclear board implementation is a smart and efficient aquaponic system. Aquaponic system is a system that combining between the two objects, which is the agriculture and hydroponic. This system is really good when it comes to keep the plant and fish always in a good condition. Aquaponic system will use the Dutch from the fish will act as the nutrient source for the plant's enlargement. So the aquarium for the fish will always clean. Based on our research, the current universal aquaponic system is not provide the efficient water control flow system. So we take this opportunity and create new innovation project about the aquaponic system as our mini project. We improvise the water control flow system to be better and added some extra features such as STM32 nuclear board as the main microcontroller and lamp as the secondary source of light to the plant. Okay, next for objective, we already list the three main objectives of the project. The first is to design the aquaponic system that efficient with the control ability. Second, to design a smart system that has symbiosis between the plant and the fish. Lastly, to design a system that have the constant light source for the plant enlargement. Then we jump to the problem statement. The first problem statement is the plant with the bad water control system. Aquaponic planting system with STM32 nuclear board implementation have been improvised to have the best water control system compared with the current universal aquaponic system. The water can flow in and flow out, also can split to the plant without any problem. Second, the plant with the low rate of source of light. Our project already has the lamp act as the secondary source of light to the plant, especially during the dark situation. So the plant will not use the sunlight as their source of light merely. The last problem statement is the high cost. Actually, the Dutch for the fish already contain the good nutrient for the plant's enlargement. So the user or the owner do not have to use extra cash to buy more artificial nutrient for the plant.
I will give a brief explanation about the design for our project, which is aquaponic planting system using STM32 nuclear board. This is the block diagram for our project. The input for our project is LDR sensor and also soil moisture sensor. Both sensor will digitally sending the input to the nuclear board. A sensor called LDR sensor will detect the presence of the sunlight. So when there is no presence of any sunlight, it will turn on the bulb to act as artificial source of light. For soil moisture sensor, it will monitor the condition of the soil. The tip of the sensor will be placed to the soil. When the moisture of the soil is below minimum value or doesn't have enough water, it will turn on the DC water pump to distribute water throughout the soil until the soil have sufficient amount of moisture for the plant. Both output DC water pump and bulb will have relay module to let the component decide when the time to turn on and turn off based on the condition. The water supply for the pump will be pulled from the fish tank under the planting base. Every time one of the output is turned on, the LED that connected to the output component will light up until the component is turned off. It allows the user to monitor if the component is working or not. This is the figure of schematic diagram and also 3D model of aquaponic planting system. As stated in the figure, soil moisture sensor will be connected to the port called PB0 and LDR sensor will be connected to port PB5 in the board. For each output, both will have connected to the LED light and also the relay module. Based on the diagram, the DC pump will be connected to PA5 and also bulb will be connected to port A4. Then this is the 3D model. We can see that the connection for the components from the input and the output. As the LED light and relay are connected in series with the output component, it is connected by using the breadboard. Other than that, we can see there is also the connection of the input and also the output of this project.
For the result and finding part, let's talk about the flowchart first. From main, the variable soil was declared and initialized to port PB0. Then another variable named LDR was declared and initialized to port PB5. These variables were declared using digital in function in order to set the port as digital input. You also can compare the flowchart with the program code here for more understanding. After that, clock for port A have been enabled by setting the register equal to 1 because port A will be used for the output components. GPIO-A model pins was cleared by initialize the register equal to C00 hexa. Then port PA4 and PA5 have been set as output by storing 500 hexa into GPIO-A model. In a while loop, if variable soil and LDR is equal to 0, PA4 and PA5 will be set by storing 30 hexa into GPIO-A ODR. If only variable soil equal to 0, then only PA5 will be set by storing 20 hexa into GPIO-A ODR. Next, if only variable LDR equal to 0, then only PA4 will be set by initialize the GPIO-A ODR equals to 10 hexa. Lastly, if both variables were equal to 1, then both output port were reset by storing 0 hexa into GPIO-A ODR. For simulation, the program code was built in Embed OS software. First, we will build the program by clicking the Build Only button. As you can see, the program was successfully built without any error and warnings. Then, we will compile the program and load the program into the board. As Embed OS is an online software, thus the binary file will automatically install and download in PC. Lastly, we load the program code into the Nucleo board. But first thing first, we need to plug in the STM32 board. Then, we load the program into the board. So now, let's see the demonstration result. For the demonstration, I will start with the water control system. As you can see here, the 12-volt DC water pump was placed in the aquarium. Water will be pumped through this tube if the soil have low moisture level. As for now, soil moisture sensor has detected water in soil, so the pump was in off condition. But if the soil moisture sensor not able to sense water, the water pump will turn on. The tissue was used to detect water evenly because soil moisture sensor has problem in sensing the moisture on its own. The first LED will light up to indicate the process. The process will always repeated. Next, moving to the light control, LDR sensor was placed at the highest part of the aquaponic system. This installation was done to make sure the LDR not detecting the light from 10-watt T8 LED. In current situation, light was received sufficiently, so the T8 LED was in off condition. But if LDR not receive any light source, the light will turn on. Another LED used to indicate the process. The process will always repeated. Advantage of this project, the aquaponic system was built in small scale, which suitable for interior decoration.
This time I will share the discussion of the project. There are a few steps taken by the students to develop the Smart Aquaponic Planting System project. The first step is the block diagram has been drawn to analyze the input, controller, and output of this project. Then, the flowchart was sketched as the overview and a raw outlining before creating the coding. The third step is that has been done is assigning the input and output of this project. The pin number of each input and output were tabulated along with the name of input and output. This table functions to make it easy to recognize the component used in the project. The next step that has been done was constructing the C programming language using Mbed OS before transferring the code into microcontroller board. Generally, this system was constructed by using two inputs, which are LDR sensor and oil moisture sensor. The LDR sensor is used to indicate the presence or absence of light, while the soil moisture sensor is used to measure the volumetric water content of soil. These make both sensors are ideal to be used as the input of the system, as the sensors are suitable for performing experiments in courses such as soil science, agricultural science, environmental science, horticulture, botany, and biology. Then Nucleo F446RE is selected as a microcontroller to control this system. The outputs that been using are menthol and DC water pump, which both works to indicate the presence of light and water. If the LDR sensor is not detecting any light, the menthol will be turned on automatically. Same goes when the LDR sensor is detecting the light or the light is visible, the menthol will be turned off. If the soil moisture sensor is not sense any water in the soil, this will trigger the DC water pump to turn on automatically and generate the water flow from the aquarium to planting tray. If the water measured in the soil is suitable, then the DC water pump will be turned off. This operation will be continued and repeated until the DC supply is cut off from the Nucleo board. According to the program code, in the line 1 and line 2, two header files named as embed.h and STM32F4XX.h is used and will be included in the preprocessor directive. The program uses the digital in function, which this is another way to declare ports as the input, as shown in the line 5 and line 6. If the header file embed.h is not included in the preprocessor directive, the digital in function cannot be used and error will be displayed. As the STM32F4XX.h header file is included into the program, hence the students do not need to define the physical address of clock, direction register, and data register belonging to the I/O ports when using the C programming language. Next, port A clock will be enabled by historic 1 in RCC AHB1EN, as port A will be assigned as the output component. In order to clear port A pins, C00 hexa will be stored in GPIO-A mode R as shown in the line 11. Then, to configure the direction register, 500 hexa will be stored in GPIO-A mode R to indicate both pins, which is PA4 and PA5 will be assigned as the output register. From line 14 to line 23, this can be seen from the program code that the system is using a while loop with a combination of 4 if statements as the body of the loop or statement that will be executed. The first if statement works to set PA4 and PA5 by storing 30 hexa into GPIO-A ODR if the soil moisture sensor and LDR sensor are not detecting any water and light. Then the second if statement works to set PA5 by storing 20 hexa into GPIO-A ODR as the soil moisture sensor is not detecting any water. As the result, the DC water pump will be turned on to transfer water needed by the soil. Next, if the LDR sensor is not detecting any light source, then PA4 will be set and 10 hexa will be stored into GPIO-A ODR. This will trigger the mantle to turn on. Lastly, both PA4 and PA5 will be reset if both sensors are detecting the adequate amount of water in the soil and light. This program will be repeated until the power source is being cut off from the system. This time, I will share with you the conclusion of this project. All through this aquaponic planting system project, the project ensures the students to be prepared to plan in designing a model of smart and efficient aquaponic system by utilizing the C programming language embedded with the Nucleo F446RE as the microcontroller. This microcontroller will be the main component, as this Nucleo F446RE will control the whole system. Before being applied to microcontroller board, the students construct and design the flowchart of the system as the first step in order to allow the students to construct a raw outlining before creating the C language coding. This system is constructed by using the ARM Embed OS application, which the C language will be applied. Moreover, students are also able to find out more about the fundamental idea of the aquaponic planting system during conducting this project. As the result, students tend to be more familiar with the design process using Embed OS, as well as understand the basic operation of aquaponic system. In addition, students also have managed to design and develop a smart aquaponic planting system using a Nucleo F446RE microcontroller, as this project works to provide efficient control ability and have symbiosis between plant and fish, as this system contains a constant light source for the plant enlargement. Lastly, the objectives of this project are achieved successfully. This project section is successfully done by the students. I think that's all from our group. Thanks for listening. Thank you.